Okay, so we've looked at all of our right triangle trig functions. We found missing pieces. We've done some complex applications. We will come back and do some more complex applications of trig. But I want to get into the next stage of things right now. And before I do that, I want to look at something like this. The sine of angle A is 0.8. How did we find what angle A was? Well, we used the inverse sine, right? And in this case, that would tell us that A is second sine of 0.8, 53.13 degrees. Is that the only possible answer? You get the right idea. So 0.8 is somewhere in here. Which gives us this angle, 53.13 degrees. There's one other spot on the circle that has a sine of 0.8. It's right here. It's positive. It's above the axis. And for the geometry of that to work out, this angle here must be 53.13 degrees. Which means the actual angle is 180 minus 53.13, or 126.87 degrees. Look familiar? And that's only on the inverse sine. And I'll show you in just a second. So when we're dealing with triangles, if we have to do an inverse sine, now we've been working with right triangles so far, so there can't be any obtuse angles. So we didn't have to worry about it. That should be a hint that what we're going to look at starting today is going to be triangles that don't have a right angle in them. So we might be able to have an obtuse angle. And we'll look at that in just a bit. So when we do an inverse sine, it could either be that angle or it could be its supplement. There's two possible answers. If we were looking at a cosine, let's say we're told the cosine of b equals 0.2. Well, cosine of 0.2 is going to be this the length right here. So that would be an angle 78.4. 78.46, you say? No. Think about it. This here is 0.2, right? Over here is this 0.2? No, it's negative 0.2 there. The angle that has the same cosine would be this one here, where this is 78.46. So that one would be 360 minus the 78.46. So that's what you were thinking before. 281.54 degrees. Can that angle ever occur in a triangle ever? No. So we're not worried about cosine. We don't care about its alternate angle. I mean, there is a second angle that an inverse cosine can be. It just isn't ever useful in application. So it's only for the sine that we've got to worry about the second possible alternative when we do an inverse sine. Why are we talking about that? Why are we worried about that? Because today we're going to start looking at oblique triangles. Oblique triangles just mean they're triangles without any special relationship. In other words, they are not right triangles. No right angles whatsoever. And if I label my triangle A, B, C as my vertices, of course the opposite sides are little a, little b, and little c, labeled by their opposite angles. Since there are no right angles in this triangle, our trig functions don't apply in the way that we're used to. There is no hypotenuse. There is no adjacent and opposite legs. because there are no legs and there's no hypotenuse if there's no right angle. But in a triangle like this, an oblique triangle, we use law of sines. The law of sines states that the length of side A divided by the sine of angle A is a constant for the triangle. Now, each triangle has a different constant, but within this triangle, the length of a side divided by the sine of its opposite angle will be a constant. So the length of side A divided by sine of angle A has to equal the length of side B divided by the sine of angle B, which will have to equal the length of side C divided by the sine of angle C. That should go on your page with your list of your trig functions. Ingrained there because we will use it quite a bit over the next couple of weeks. So let's say that we are given, that's a 72-degree angle. This is 14 inches. And this is 44 degrees. I'm going to label it A, B, and C. So obviously this is little a, little b, little c. Find C, real easy, doing what? You got 180 minus 72 and minus 44, which is what, 64 degrees? Look right? You got it. And that's what the first thing we have to look for is, do we have a side in its opposite angle or an angle in its opposite side? We do. We have the 14 and the 72 degrees. So you're exactly right. 14 over the sine of 72 degrees is a constant for this triangle. Now, let's pick a side. Which side do we want to find first, B or C? B. So we're looking at side B. Over, what's its opposite angle? So its opposite angle is 44 degrees over the sine of 44. So now to find B, it's going to be 14 times the sine of 44 divided by the sine of 72. So 14 times sine 44, close, divided by sine 72. 10.23 inches. Now I'm going to stop there. Does that make sense? Yeah, it does. It's smaller than, 44 degrees is smaller than 72, right? So it makes sense for this side to be smaller than that side. Longest side opposite the largest angle. Now before we start to calculate side C, what do we know about its length? No? It's between them, right? 64 is between them, so it better be between 10.23 and 14. Just little thoughts like that help avoid some careless errors. You know, if you miss a button on the calculator or hit an extra button on the calculator, it can give you an outrageous answer. By just that quick double check, it can catch that. So we're still going to do the 14 over the sine of 72. But this time it's going to be side C over the sine of 64 degrees. One little side note, I've told you in the past that whenever possible, always go back to original information and never use something you've calculated to try to calculate something else. When we get into the law of sines and then tomorrow in the law of cosines, we're going to have to use stuff we've calculated. There's just no way. It just builds on top of each other. You're going to have to keep going with it. No way around it. So anyway, here we are. We're going to cross multiply and divide. 14 times sine of 64 divided by sine of 72. And we get 13.23.
Can you go back?
It's not degrees, it's inches. Sine of 72. Did it work?
Yeah.
So in this case, we were given two angles and one side. That is the simplest possible case. Because if we have two angles, we have the third angle really easily, right? And if we got three angles and one side, it's pretty simple. We'll look at more examples of that as we go on, but for right now I want to jump to the other possible case, where we have two sides and one angle. This can be more difficult because there are four possibilities really, but possibility one, everything's normal, A-okay, just do it. Possibility two, it's not a triangle. Possibility three, could be two different triangles. Possibility four, can't solve it. So we're going to look at possibility one first. It's normal. So in this case, I'm going to give you side A up here is 15 inches, and side B over here is 12 inches. And I'm going to give you angle B here, it's 40 degrees. First thing we always check to do, find side and opposite angle. Do we have a pair where we know the side and its opposite angle, or an angle and its opposite side? We've got B there. So that's going to be 12 over the sine of 40 degrees. Now the only other piece of information we have here is the 15 inches. That has to go on top because it's a side length. Now I'm going to do a little side note by the way, some textbooks have the sine of the angle over the length of the side. It's just flipping the whole proportion over. It's going to work out the same. I prefer to do it this way because I like the ratio comes out to be a large number instead of a really tiny decimal. But it works out the same. Different textbooks do it differently. So 15 is going to be over the sine of what angle?
A.
Angle A. So now we're going to cross multiply and divide. Sine of 40 times 15 divided by 12. We get 0.8035. Now this is not our answer. Why not? Yeah, that's the sine of A that equals that. So A is going to be the inverse sine of that. Now I'm not going to punch it back in my calculator. I'm going to do second sine and then second answer. ANS brings up the previous answer. That way I don't have to write it down and type it back in. I get 53.46 degrees. Now at this point, I need to find side C. Or angle C, I should say, right here, right? How am I going to do that? Add them together, subtract from 180. So 93.46 from 180 is 86.54 degrees.
I'm at 53.6. Obviously, we did a bunch of other numbers. Why do we ignore all of them?
I mean, after the 4.6?
Yeah.
I'm just rounding to 2 decimal places. You got to round it somewhere.
Okay.
I've just chosen to do 2 decimal places on my angles.
Would that answer be correct with that now?
The whole thing?
Yeah.
Yeah. But every shop you're going to work in is going to have different standards for where they want things rounded and stuff like that. And different applications, it's appropriate to round. Other applications, it's appropriate to go to 4 or 5 decimal places, depending on how precise you have to be. So now I can find side C. I've got my 12 over the sine of 40 still. Side C over the sine of 86.54 degrees. And I can cross multiply and divide. So 12 times the sine of 86.54 divided by the sine of 40. 18.63. So that one worked out pretty neat. So there was only one possible triangle we could get out of that, and there it is. You'll notice, by the way, there is an extra step here. It's not just cross multiply and divide. We do have to do the inverse sign after we get the answer in that first step. That's inches, you're right. I don't know, I've done that twice this morning so far. It is 18 inches, not degrees. So now, we said there were 3 other possibilities. We're going to look at one of them right now. So we have our triangle ABC. If that one's normal, yeah. Let's say that this angle here is given as 58 degrees. Side B is given as 8 inches. Side C is given as 13 inches. Looking at this triangle, what's the first thing we always do when we look at an oblique triangle? We try to find a pair of a side and its opposite angle. Do we have that here? No, we don't. We can't solve this. For now. Tomorrow we'll learn something called the law of cosines. Nope, we're not given those. If we were given those, we could solve it. But we're not given those. We're just given the 2 sides and the angle in between them.
There's no law like
Well, they all have to add up to 180 degrees, but we only know one of them, so we can't find the other 2 quite yet.
Oh, yeah.
Law of cosines, though, tomorrow will help us find that. We'll get it, don't worry. I won't leave you hanging for very long.
Except it'll snow tomorrow and you want to have class and you forget.
I'll just sit at home and lecture and record it for you. I have to. So anyway, let's see one of the other possible options. This one here. Once again, we have two sides and an angle. Danger warning here. The side opposite the angle is shorter than the other given side. Here's my angle, 19. Here's the side opposite. That's shorter than the 12 inches. Now, in the last example, it was too, but I made sure that one worked out just fine. When this happens, there are actually two possibilities here. It could look like this, or it could look like that. This 19 degrees is going to be the same. This 12 inches is going to be the same. And this could be 6 inches going in either direction here. How do we know which of those possibilities it is? Well, in this case, we have the picture. Yeah. But what if we don't have the picture? What if we're just given side B is 6, angle B is 19 degrees, and side A is 12? Then there's going to be two possibilities. In this drawing, though, we can clearly see that A is an obtuse angle. So if we're not told whether that's an obtuse or acute angle, there will be two possibilities. Why does that being obtuse angle affect us? Well, let's take a look. We have our 6 inches over the sine of 19 degrees. That's going to equal 12 over the sine of angle A. So we shall now cross multiply and divide. Sine of 19 times 12 divided by 6 gives us 0.6511. So we're going to go ahead and do our inverse sine. And again, I'm not going to punch it back in. I'm going to use the calculator to do the work. Second sine, second answer. 40.63 degrees. Yep. No, there are no right angles in here. No right angles. That's what the oblique triangles. So everything we're going to do today and tomorrow and for a couple of days will have no right angles in it for a while. Right. No. Is that my answer for A? Say no. Why not? Yeah, A is obtuse. 40 degrees is not obtuse. Remember, we just talked about this a little while ago. When we do an inverse sine, there's two possibilities. The angle the calculator gives us and its supplement. A is really 139.37 degrees. Which means C up there has to be 21.63 degrees. How'd I get C? 180 minus 139.37 minus 19. Now I can find side little c down here. Because I know I still have 6 over the sine of 19. Little c is going to be over the sine of 21.63 degrees. 6 times sine of 21.63 divided by sine of 19. 6.793 inches. So the difficulty there is the fact that that's an obtuse angle. And since it is an obtuse angle, There are two possibilities. Now here we had the picture that showed us that it was obtuse. But we might be given information that looks like this. $6.793, yep. When we're given something like this, this is the angle in its opposite side, right? A and A. The other side is longer than the side that's opposite the angle. So here's where we end up with the danger. There will be two possibilities here. Like this. Or like this. How do we know which possibility is going to be? We don't right now. We have no clue. Could be either one. If I tell you that, though, now I know that it must be that possibility, right? If I tell you that B is an acute angle, does that make sense? Whenever you have that situation, angle B could either be acute or obtuse. So we have to know which. So then, let's go ahead and solve. I'm going to put some information in here. 13 degrees, 5.2 inches, 10.9 inches. So we have 5.2 over the sine of 13 degrees equals 10.9 over the sine of angle B. So we will cross multiply and divide. Sine of 13 times 10.9 divided by 5.2, 0.4715. So B is the inverse sine of 0.4715. So again, I'm going to keep it in my calculator, second sine, second answer. That way I don't have to round off of typing it down and punching it back in. 28.13 degrees. So what you come up with? Perfect. I'm going to assume you guys can take it from there. You can find angle C by just subtracting from 180, and side C then is just our simple equation. I'm going to give you one to try. Try that one in your notes quick. Some of you may have been noticing something by now. So if we label this as 8, 17, and 31 degrees, we go to solve this. 8 over the sine of 31 degrees equals 17 over the sine of B. Now we have that same issue again, where the side that's opposite the angle is smaller than the second side that's given. Right? We cross multiply and divide here. Sine of 31 times 17 divided by 8 is 1.0945. Now, before I even try to type in an inverse sine, can anybody tell me why it's not going to work? Yeah, sine can never be larger than 1. Neither can cosine. This can't work. What this is saying is, If I have an angle of 31 degrees here and this side is 17, 8 inches isn't long enough to reach back down to here. So it doesn't matter whether it's acute or obtuse. It can't be acute or obtuse. It can't reach. Make sense? It'd have to be like 8.6 in order to reach down there. Okay, I believe I've got to give you a new packet. Check and see. This is page 381 in your packet, 1 through 17. I don't think 381 is in your old packet. I think I'm going to give you a new one. It ends at 384, so you've got it in there. Perfect. I don't have to give you a new packet.
No, 374.
374? Okay, I'll get you the new one right now.